Hi, my name is Claire. This is Magna, and this is Claire. We're going to be talking about supercapacitor. Supercapacitor is a combined version of capacitor and battery, so it has high energy material and high power. Solving energy storage issue enables new technology like supercapacitor. It used various transportation industry like buses, racing cars, and trams. Supercapacitor can be charged really fast and often, and it has enough power to go to the next stop and then can be recharged. So this process can be repeated several times. It is very interesting topic to improve energy stores and charging cycle. Already in China and Japan, they've been using this technology in trams and buses. Nanoscience in this topic is that nanoscale particles are very useful since it has very high surface area. Now we'll be explaining about the analogy and then supercapacitor in more depth.
So in this drawing, we're going to be talking about batteries and capacitors. So a brief explanation of what they are, which Claire will go more into depth about later, is battery is basically a source of energy which provides a push or voltage of energy to get a current electrical energy flowing. And a capacitor is similar, except it only provides the sufficient energy needed before it gets to the next stop, so just providing enough energy. And then supercapacitor is almost the same, except it can be charged and discharged continuously. So this drawing is supposed to be a model of an experiment we did this morning in which we tried to create a representation of a supercapacitor to try to get a red LED light to flash. So in this drawing, if you can tell, it's split into 3 parts, and each part is supposed to represent either a battery, capacitor, or supercapacitor. If you look towards the bottom over here, it shows how much energy or nutrition each dinosaur is taking in. So at the bottom, the lowest dinosaur is taking in the most energy with plus 100, but it's producing the least amount of power. So it's the slowest one, meaning that it would be the battery because it needs the most energy or it stores the most energy, but produces the least power. The middle dinosaur, first of all, the dinosaur is significantly larger than the other two, and supercapacitors are significantly larger in surface area compared to a capacitor and a battery. And in this one, if you can tell, it stores the second most amount of energy, but by the arrow you can tell that it's the most powerful or it moves the fastest. And at the top over here, this is a capacitor, and you can tell because it stores the least amount of energy with just plus 10, and it's still faster than a battery, but slower than a supercapacitor.
Okay, so something this analogy doesn't really go into depth for is what's going on internally. So the reason why the battery is so slow is because actually the ions travel through it, opposed to the capacitor and the supercapacitor where the ions travel on the surface area. So basically in the battery you have the lithium ions moving from the cathode to the anode, but unfortunately this is a really slow process. So it can store the most amount of energy, but it is the most slowest. So that's why it's kind of like when you're charging your phone, you get frustrated because it takes so long to charge. That's what's going on in the battery. It's the process, the lithium ions taking such a long time to actually complete the process. Now with a capacitor, it's actually much faster than the battery because unlike traveling internally with the battery, the ions actually travel on the surface area. And surface area and distance is a really big part of the process. So in a capacitor, you have 2 plates, one with the negative charge and one with the positive charge. And basically, the position results in a relationship where it's very easy for these charges to pass an electric current, which makes the energy. So that's why this is a much faster process in the battery because it can actually send an electric current at a much faster rate than the battery. Now with a supercapacitor, it contains assets from both the capacitor and the battery to ultimately reach the goal of making the most efficient product. So it is much faster than both of them because unlike the capacitor and the battery, it actually doesn't contain plates and the ions don't travel in the center. You have a porous nanomaterial, and since it's porous, it actually has a lot of surface area. So you have the negatively charged ions on the surface area, and since it's such a large surface area, you can have a lot of ions. And you also have the negatively charged ions right next to it. So you can look at this relationship and see that they're very close to each other. So it's really easy to send an electric current back and forth, which makes it the most fastest one. But unfortunately, it is not it can't store the most amount of energy. So that's kind of the challenge when we look at supercapacitors. We have the speed, but it's like, how do we make it store the same amount of energy as a battery can? So that's kind of what this emerging field is trying to explore that concept a little bit more. So we can eventually like put this supercapacitor that functions like a battery and a capacitor at the same time into things we use in our everyday lives. So yeah, thank you.
Questions?
So a common application for supercapacitors and batteries are in electric vehicles. So in what would a supercapacitor be able to do in an electric vehicle, and what would a battery be able to do in an electric vehicle that's different from each other?
So, go ahead. Okay, I'll do supercapacitor and you can do battery.
Okay.
So an example of a supercapacitor is there's a bus, I think, in Japan that what it does is, as I said earlier, supercapacitor just charges like sufficient energy from like, for example, one stop to the next. So at the first stop, the bus would charge just enough to get to the next stop in like the 20 seconds that it's waiting for passengers to load like on and off. And then at the next stop, it would charge just enough to get to the next stop and so on.
And with the battery in cars, so it has to go a farther distance in the bus, and it also doesn't have constant like charging pads, which the bus can go over. So that's why you would use a battery. But it also doesn't. So it stores more energy than a supercapacitor. So it stores more energy than the bus that Magna was talking about, but it is a lot slower process to recharge because it's a chemical reaction and not something on the surface area.
So if you remember from your lab today, when we actually pressed the switch, you guys could only see it for like a second, right? So what's different? What do you think is different about like your supercapacitors that make them like not as good as to compared to like someone who like makes really good supercapacitors?
Like what was wrong with our supercapacitor?
Well, there wasn't anything wrong with it. It worked. So like, why do you think it was not as good though?
Well, the wires we used were...
I'm talking about the actual like device you made.
Why it's not as good as like professional ones? Like, is that your question?
Yeah. So like, what do you think were like some like flaws in like the design? You guys remember that you put the carbon on each slide and you matched them up and then you sliced them together with like citric acid on top, right? Mm. So like, what's something you would do to like make it brighter or something like that?
Make it what?
Like,
brighter
for a longer time.
Like it couldn't have had enough. It didn't store enough energy as a supercapacitor is supposed to. It was like only storing the energy that a capacitor did, which didn't give enough like energy to go as fast as a supercapacitor should.
So like if you remember the equation, like what's something in the equation that are adjustable variables for like a good supercapacitor?
Oh, the surface area and the distance between the particles. So in the ones we made today, so yeah, surface area and distance are basically like the two main principles when you're talking about these systems. Because if you have a wider surface area and a smaller distance, you can have a more faster process. So I'm guessing it has something to do with the distance and how much surface area. Well, I know that we used carbon, I think nanotube, and so it's porous, so it has a lot of surface area. So I'm pretty sure it has something to do with the distance between the charges.
All right, thank you.
I have another question. So there was a plot that Dr. Tolbert talked about when she gave you her talk, and that your instructors also talked about with reference to batteries and capacitors and supercapacitors. Do you remember what that plot was called?
I think it was, I don't know if this is the exact name, but like Rogens?
Very close, yeah.
What is it?
It's called a Ragone plot.
Okay, so
right?
it was like, so on the x-axis, I'm pretty sure it was density energy, and on the, I have it here. So the energy density, and on the y, it was the power density, and it kind of, the trend is like that.
So can you describe, so what would be where on this Ragone plot, and why? Like what is it saying?
Okay, so a battery is going to be
Near the energy, and then the supercapacitor will be like kind of like in between, like in the middle of it, and then capacitor will be more towards the power.
So that means that the battery is doing what?
It has more energy in it.
Right. And
But
the
it's the
capacitor,
slowest.
but it's slow.
Yeah.
The capacitor,
has
on the other
lower
hand,
energy,
but
but it's a
it's
much faster
faster.
process.
right. And
And
so
like a
it's
supercapacitor lies in the middle. It
Nice.
tries to
It's
take
like
assets from
combined.
both.
awesome. Any other questions?
When you're referring to the speed, is that the speed of charge or the speed of discharge?
So when we're talking about speed, we mean like the amount of power that it's releasing. Especially in this analogy, if you can see, the arrows are supposed to depict how fast the dinosaurs are moving. So the amount of energy it takes in is relative to like how fast the dinosaurs can move. So we're talking about the energy it's releasing, or the power it's releasing.
But are they different? How fast it goes in and how fast it goes out? Like, can one be slow and the other fast?
Like how fast it takes to charge.
Uh-huh.
I'm not
Between
sure.
a battery and a supercapacitor?
Yeah, for any of them.
Yeah. The process for a supercapacitor is much faster because it's not a chemical reaction.
Yeah,
So you
but
don't
charge
have, like-
versus discharge.
Oh. I think it's the same.
You got it. It is the same. Which one do we usually care about?
Discharge? No.
Charge.
Charge.
Well, it depends what you're doing. Where would you care about charge?
When you're like charging like your device or something like that, and you want it to
Yeah.
go quickly.
Where would you care about
maybe, like,
discharge?
A
When you're
car,
releasing the energy.
when like how much energy you can release. Like for the buses, like the discharge is really important because it has to match the amount of distance it has to go in order to go to the next like charging pad.
No, but the speed. You were right. Buses is a big one. Why would you care about how fast it can discharge? What would that relate to in a bus
Oh, the people getting
or car?
The speed.
The acceleration, actually, how fast you can accelerate, because it takes a lot of power to accelerate. So if you don't discharge fast, then you would have a very little lady kind of bus that would not speed up very fast. So that there are certainly places where you care about the speed of discharge, and certainly cases where you care about the speed of charge. But luckily, they're pretty much the same, so you can get whichever one you want.
Yeah, nice job. Thank you, guys.
Thank you.